All right, today I'm going to show you how to solve quadratic equations by factoring. I'm going to start with the easier of the quadratic equations where a is equal to 1 or a is equal to -1. So we're going to do a quick review here, and remember that you always want to factor the GCF if there is one, so you're always going to look for that when you're factoring no matter what. And if there is a factor of -1, that will only occur if you have a negative x squared in the problem. So your first term is negative. You would take out the -1 immediately as a GCF. Otherwise, you'll look for GCFs like 2 or 3 or 4 or something like that. The next step after you try to factor out a GCF, if there is one, and if there isn't, you would just skip to 2. But if there is one, you do that first. And then you go to whether or not you have a binomial. And if it is a binomial, a difference of squares, meaning you have something like x squared minus, there's your difference, like 4, or x squared minus 16, or x squared minus 25, where x squared is a perfect square, and each of the numbers that are being subtracted are perfect squares. So you're going to look for that. If it's x squared plus 4 or plus 16 or plus 25, then that's not a difference, so just be careful of that. If it's not a binomial, we're going to look to see if it's trinomial. If it's a trinomial, we're going to do our diamond problem, okay? So that's our review, and let's take care of our first problem. All right, so problem number 1, okay? We're going to solve quadratic equations by factoring. Okay, x squared minus 5x plus 4 equals 0. Now, typically, our equations will equal to f of x or equal to y, because f of x is just another name for y, a function of x, right? But because we want to solve them, what we're really going to be doing is look for the x-intercepts. That's the whole meaning for this. So we are looking for the x-intercepts of the quadratic equation. So what we're really doing is finding x-intercepts. I'll put that down here. All right, so that's our goal. And to find x-intercepts means that your parabola or your graph has to be crossing the x-axis. Okay, and when any graph crosses the x-axis, that means your y value is 0. So that's why instead of having equals y or equals f of x, we are replacing our y value with 0 so we can find the x-intercepts. All right, and as you can see, this is a graph of the function that we are going to solve to find where those x values occur. All right, so number 1 rule for solving all the quadratic equations. All quadratic equations, and I'm going to abbreviate here. So all quad equations must equal 0 to be solved. Otherwise, you can't solve them. Okay? So if they don't equal 0, we're going to have to make that happen. But let's start with our first one. Okay? So what we're going to do is we look here and we'll look for a GCF, and 1, -5, and 4. Well, the GCF is 1, so we don't take that out. X squared is positive, so we don't have to worry about a -1 to take out. So we go right to our diamond. Okay, remember our diamond is the first and the last term get multiplied into the top, so it's 4. And our -5 goes into our bottom of our diamond, and then we complete the diamond by looking for factors of 4 that can add to 5, and they would be 1 and 4. 2 and 2 wouldn't work because they only add up to 4. Now, we needed to add to a -5, but multiply to a +4. So we make them both negative. All right, and just double check. -1 plus -4 is -5. -1 times -4 is 4. So we're good. So our factors now, this is the fun part. Our factors are 2 binomials. They still equal 0 because you're just changing this equation to be 2 multiples. X and x give us x squared, and from the diamond that you completed, you minus 1 and minus 4. And now we have to solve. So now that we've factored, we continue solving like we did for pre-factored quadratic equations. Okay, we set each factor equal to 0, because one of these has to be 0, and we got to find the x values that make it happen. Now again, I know we can guess them. This is 1 and that's 4, obviously. However, in algebra we need the proof, and here's our proof. So we set x minus 1 equal to 0 and solve, and we get x equals positive 1, like we said. And we set x minus 4 equal to 0. We add 4 on both sides, and we get x equals 4. And those are our x-intercepts. So if we look back at our graph, we can see that our x-intercept was 1 and 2, 3, 4. 1 and 4, and that's what we got. All right, let's look at another problem. All right. Again, remember, all quadratics must be equal to 0 to be solved. This one is not equal to 0. It's equal to -8. So what we have to do is a little moving around. We're going to bring that -8 to the other side by adding it. And that becomes a big fat 0. So we have x squared plus 6x plus 8 equals 0. Remember, 8 can't be combined with x or x squared because they're unlike terms, so we have to just add it on. So now we'll do our diamond, and I'm going to do my diamond over here on the side now. 1 times 8 goes in the top. 6, the middle term, goes in the bottom. To complete my diamond, I need factors of 8 that will add to 6. So I start with 1 and 8. That doesn't work. 2 and 4, that could work. They're both positive because they have to add to a positive 6 and multiply to a positive 8. So now we do our factors. Equals to 0. Don't forget that. X plus 2, x plus 2 and x plus 4. Now we solve. So we set x plus 2 equal to 0. So we subtract 2. Watch your signs. X equals 2. Please don't skip steps, because then you can mess up a sign. We set x plus 4 equal to 0. We subtract 4 on each side, and x equals to -4. So -2 and -4. There we go. I had to put that negative on that too. Those are our two x-intercepts for this parabola. If we graphed it, we would see that that is where it hits the x-axis. All right, let's try another one. What we're really doing when we solve is finding the zeros of the function, so hence finding the zeros. That means, where is the y 0? Well, on the x-axis, of course, so we're finding the x-intercepts. So what we're going to do is we find the zeros, we're going to put 0 in for y. So again, all quadratics must equal 0 to be solved, so we set it equal to 0. So if you don't like it looking this way, that's fine. You can switch the sides, just flip it around. So you can do x squared plus 4x plus 2 equals 0. You can do that, there's no problem. Now let's do our diamond. Okay. All right, get our diamond off to the side here. 1 times 2 goes in the top of our diamond, 4 goes in the bottom. And we're trying to think of factors of 2, and 1 and 2 are the only ones that we know of. So we put 1, we put 2, and what happens is your diamond fails. 1 times 2 will equal 2, but 1 plus 2 will equal 3. And there are no other factors for 2 here. So therefore, this fails. So what we say is, it's not factorable. And believe I introduced the idea, the concept that there's imaginary numbers out there that you're going to learn somewhere in Algebra 2 about midway through. And that's what this means. It means that there are no real number solutions for this one. They would be imaginary. So for us in Algebra 1, what we're going to say here as far as getting a solution to x is there are no solutions. And your evidence is that the diamond fails. We can't get factors, so it's not factorable, so therefore there are no solutions. All right, let's try another one. All right, what if we had solved -2x squared plus 4x equals 0? Well, we have an ax squared and a bx, but we don't have a c, but that's okay. We don't need to have every single term to factor. So what we got to do first is always look for our GCF, and our GCF here would be 2 and 4, right? So we get a 2 out of that, but because the first term is negative, we take out a negative 2. So that'll leave us with positive x squared, and a negative 2 divided into positive 4 will give us a negative 2 again, and x equals 0. And if you want to do a quick check for yourself, okay, easy enough to do, negative 2 times x squared, negative 2x squared, negative 2 times negative 2x, positive 4x. So you know you're good. All right. Now, what's strange about that is that each of these terms have to be set equal to 0. But I noticed something. We actually have an x in both of these, so we really didn't factor correctly. And that's going to happen to you periodically, is that you won't factor out just the numbers, you forget about the variable. So let's start this again and just look at it and say, wait a minute, that can't happen. So we'll bring this down here and say, all right, taking out the negative 2 is great, but remember our rules. When we have variables, we have to take out the variable if it's in every term. So it comes out, and we take the lowest power of the variable we see. That's power of 2, that's power of 1. So we can only take out 1 power. Now we should have no problems. Negative 2x divided into negative 2x squared is going to leave us with a positive x. Negative 2x divided into a positive 4x is going to leave us with a negative 2. And that looks better. Okay, so what we have to remember is not to make this mistake up here and not factor out a variable. If there is a variable in every term, it still has to be factored out. All right, now our rule is to set each factor equal to 0. So negative 2x, as weird as it looks, it's just a monomial. Okay, it doesn't have to be a binomial. It is a term and it is a factor, and it gets set to 0. And when we solve for x, we're going to get x equals 0. That's one of our answers. That's where one of our x-intercepts is. Then we set x minus 2 equal to 0. And we add 2, and we add 2. And so x equals 2. So our two x-intercepts are x equals 0 and x equals 2. Okay. All right, we have another one to do. And this, I think, is our last one. Oh. Got one more. All right, so we got negative x squared minus 4x plus 12 equals 0. So we're just factoring to solve, okay? Great. Because we have a negative in front of the x squared, automatically a negative 1 is going to come out. But let's just make sure there's no other GCF. So negative 1, negative 4, and 12, we can only take out a negative 1. We don't have x in every term, so we can't take an x out. So when we divide negative 1 into negative x squared, we're going to get x squared. Divide negative 1 into negative 4x, we're going to get plus 4x. And divide negative 1 into 12, and we're going to get minus 12 equals 0. All right, so you keep that GCF out there, okay, and don't lose them. Now we're going to do the diamond on this guy. All right, so 1 times negative 12 goes in the top, and 4, positive 4, goes in the bottom. Now, factors. Factors of 12 that can give us a 4. Well, 12. 1 and 12, not getting 4 out of that. 2 and 6, that's got potential. 3 and 4, not getting that. So we're going to take these guys. 2 and 6. The highest number has to be positive because it has to add to a 4, a positive 4. So 6 will be positive. 2 would be negative. And double check. Negative 2 times positive 6 is negative 12. Negative 2 plus 6, or 6 minus 2, is 4. So we're good. Keep your GCF of negative 1 out there. Open up your binomials. And we got x minus 2 and x plus 6. Set each factor to 0. Now, because your negative 1 GCF is just a number, obviously negative 1 doesn't equal 0, so we can eliminate that. And that's kind of silly. We can't solve for x, but we can take x minus 2 equal to 0. And we can take x plus 6 equals to 0 and solve each of those independently. And we will find where this parabola, if we were to graph it, crosses the x-axis. All right, so it crosses at x equals 2 and x equals -6. And remember that GCF of -1 gives us a negative x squared, which means it's going down when we do graph it.